our footings, we always come through, we do our external footings first. We then come in, we do our continuity, so we just extend the corners the whole way through, and then we start worrying about infilling our other beams here. So it's the same systematic approach for every foundation problem that you have. Just as you go through the course and future studies, we learn better how to put these in place to save on cost. So we're going to go through and design some footings now. Just going to open up the AS2870. Just going to go through just some fun facts for you while we're here. So it goes through everything. This code goes through everything for our foundations. So this part here is going through our drainage requirements, how we have to set down areas, slope them away from the building so we don't get water pooling next to our walls. Then comes through, tells us about the concrete. Typically we take 20 MPa concrete. We have to have a slump test of 100 millimeters. You'll learn this through your studies. It's just a test that we do to make sure that our concrete grade is sufficient, as well as compressive tests. We get reinforcement details here about the overlapping of the mesh in the slab. Goes through, tells us about the vapor barrier. This here is our damp-proof membrane. That's the Forticon, or the I think in the last recording it was either like a blue grey kind of tarp or the orange plastic sheet that they put on the ground. That's this here. Okay, that's what it's for. It keeps going through, tells us about everything to do with our foundations. Our edge rebates, where our brick's sitting. Alright, so we've got a minimum edge rebate of 20 millimeters. Typically we take 25, and this rebate is shown here. Alright, so this is 20 millimeters here. Alright, this little bent thing here is a damp proof course. Again, that's any moisture that pulls in here to seep back out. Damp proof membrane runs the whole way around the concrete. Alright, we keep going, and it keeps telling us how we put in set downs or our recesses into our slabs, how we put the reinforcing in between it. This here is our reentrant corner bars, those 3N12s that are 2 meters long. So when you come to the topic, you'll have to read through the entire code, and I recommend reading through the entire code. This one's probably one of the easier ones to read. And it will keep going. It will tell you that your pipe work coming through your footings cannot go. They have to be in the middle third of the footing depth. Worth a read. I encourage it. Probably wait until you're doing the subject, but it's a nice light-hearted read. And worst case is it will just send you to sleep. So let's go through and design some footings. Page 30. Page 30 is a table that I will give to you. Alright, and I'll give you all the other information required when we design our footings. So this here you're going to become very familiar with. I will give you the site class and the type of construction. You will have to determine the rest. So for today we're going to use a H1D articulated masonry veneer. Alright, so site class or site classification is a H1D. Alright, and what we're using is articulated masonry veneer. So we just keep coming across. So for this foundation, the depth is 500 millimeters. We ignore the mesh. Remember, this is interstate, not in South Australia. South Australia, we use the bar alternative for our bottom reinforcement. So we use 3N12s down the bottom. And this is our top reinforcement. We've got 2N12s up top. And we've got our spacing requirements here. We've already taken care of this when we've done our footing layout. So we just have to do these other 3 now. So let's go ahead and draw the cross section. So footings, I'll do a polyline. And let's just zoom in over here. These are going to be scaled at 1 to 10. Most of our details are scaled at 1 to 10. So let's start a line here. Let's make it say 500. Okay, so it's not very big. I'm just going to zoom right in so I can see it. So this is going to be the top of my slab. I'm then going to come down for my recess, which is 25 millimeters. Then I'm going to come across. So in this rebate here, my brick course and my thermal gap are sitting there. So remember, my brick course is 110 millimeters and my thermal gap is 40 millimeters. which means I have 150 millimeters sitting here. I'm then coming down for the depth of my footing. Now the depth is measured from the top of the slab, so I'm coming down 475. Enter. My footings are 300 millimeters in width, and then I have to come up some amount. I'm going to come up 250 to start off with. Escape. Don't know how far up I'm coming yet. So what I'm going to do is this line here is the top of my slab. I'm just going to draw another line over it to there. Going to select it, move. I know the thickness of my slab is 100 millimeters standard. Okay, if we have more than 200 millimeters of backfill, we go up to a 125 millimeter thick slab and 2 layers of mesh. But for our case, we're taking it simple, 100 millimeters. Enter. So this is this one here. What else do I know? Well, I know that this 45-degree angle, if I come back to my standard, I think it was page, maybe it was 52. Yep. This is what I'm talking about now. So we've come across, we've come down by 25, we've come across to allow our brick and our thermal gap, then come down for the rest of the footing. It's 300 millimeters wide, and now I'm back up here somewhere. So this length here has to be greater than 50, or equal. Okay, greater than or equal to 50. So let's take 50. Let's do a line from here, 50, enter. This is not very big. Let's rotate this by 45. Now this has to touch this, so stretch, select everything I want to stretch, here, straight up to where it connects. Trim, and I can trim this line. Okay. I also know for later, if I copy this down, I have 100 millimeters of blinding sand, which is going to help level everything out. So that's going to sit down there. Let's just extend this out to where it connects. Cool. Awesome. So this is the first kind of leg there. Now what I'm going to do is just stretch these out a little bit. Because it's a cross section, there's a lot of visuals here. Alright, so it's very much so how we can present it, more so than the actual measurements of it. So that will make sense as we go through it. But I'm going to mirror, because I have to have one in the middle here. So I just try and find the midpoint, alright, which is there. No. Can I mirror this again? Probably not. So what am I going to have to do? Well, I know this dimension is the same. So move to here. Then I'm coming 300 for my footing. Select these two. They're on the other side. So mirror from here. Cool. And now what do I know? Well, I have the same thing of this over this side. Okay, if I look at my footings, it's going to be on page, try 30. Maybe not. This one here. Basically, I have this on the other side. So we're drawing just 1, 2, and then a mirror of that. So what I can do, select all of this, mirror about this midpoint, go no, and then effectively I can just connect these here. Alright, so this is how we're starting this cross section. At the moment it's not the most attractive thing in the world, but it will get there. Alright, if you want to make it look a bit better, we can just stretch these out a little bit more, say 300. Cool. Now let's go ahead and put in our reinforcement. So let's put in our cage. I'm going to assume a 20mm cover. So offset by 20, in. So what do I get? I get a cage that sits here to here. Alright. In reality, what will happen is this will come up. Alright, it doesn't sit like this. They actually tie it up to here and back down. But for understanding how to draw these cross sections, this is okay. So I've got one here. Now what was my reinforcement? Well, let's bend these first. So these cages aren't square. They've got a bit of a radius between them. So if I fillet, radius, 25 is probably a bit much. Let's aim for 15 and see how we go. There to there. So a little bend, that looks okay for now. Kind of like we did when we looked at our doubly reinforced beams. Cool. So what was my reinforcement down the bottom? Well, I have 3 N12s in the bottom and 2 N12s up top. So circle, 6, radius of 6 gets me a diameter of 12. So let's move one to the middle. Alright. Now they are very small compared, and that's okay. When you study concrete, it will make a bit more sense that the steel is actually very much so a lot stronger than the concrete. So all I'm doing now is just reasonably placing these in here. Okay, I'm not going to line them up exactly. This is going to be okay for illustrating the typical cross section. Nobody's going to measure off these drawings, so we can be a bit more crafty with things. And I have 2 of them up top. Awesome. So that's my reinforcement. 3 N12s in the bottom, 2 N12s up top. So now I've got this. I might move these because of my OCD. It's going to annoy me. Let's tuck that one in there. Delete this one. Mirror to here. Alright, that's much better. Makes me a bit happier. Okay, so I've got them. Copy. So where are they sitting? Well, they're sitting in all 3 of my footings. So 1, 2, and 3. So all of these have 20mm cover between here and here, here and here. That's a clear cover. Okay. We have to put a cover here to protect our steel from any kind of corrosion. So that's these done. Now what do I have? Well, I'm going to draw a line across here. I'm going to take a 20mm cover for the slab as well. So move this down by 20. This is touching here, so it has to come back in by 20. And same on the other side. Alright, so this is the mesh that's in the top of my slab. What is that mesh? We haven't designed that yet, so let's have a look. Come back here to this table. Note, slab reinforcement for all site classes shall be as follows. So this is dependent on the length of the building. So how do I know the length? Well, I've got the plan, so let's measure it. Measure from here to here, which is the longest length, it's 25.2. Now, I know what you're all thinking is, well, this section here is shorter, this section here is shorter, then so this one's the biggest, right? So in theory, I can have SL72 here, SL82 here, and SL92 here. That's what my standard says. is I can have SL72 where my slab length is less than 18. When it's between 18 and 25, I can go to 82. And when it's greater than 25, less than 30, SL92. Okay, so I can have 3 different types here. Now we don't do that. The reason why we don't do that is because what happens is if the trade that I get, he's been out, he's come to work, you know, all these mesh kind of look alike, and he rocks in and he puts in the SL72, that should be here, across this long strip. Well, that's not going to be sufficient for here. It's going to crack all through my concrete. So we'll just make the entire area all one type of mesh. So as a designer, everything we do, we have to make sure that we understand, I guess, the economies of scale and kind of what happens where it might cost a bit more, but the error and the risk we can see happening if a mistake is made all comes back on us. So we will take SL92 for the entire slab. Hopefully that makes sense. But long story short, this is the one that we're using. Alright, now what are these? Okay, well, 9 is the diameter of the bar. 2 means 200mm spacings. So how do I draw that here? Well, circle. 9, so 4.5. I then move it, so here to here. Move from this side to here. Cool. And now what I need to do is copy, or you can use an array. I prefer to copy it. An array you can have a couple of issues with later. So it's from the center. So center to center is 200. So 200, 400, 600, 800, 1000, 1200. I'm not really too sure how long I've done it. So got all of these. So I might select a few of them to save my time. Copy. Well, if I copy from the midpoint of this one, I can then copy to this one. How many more have I got? I've got one more. To there. Alright. Now what you're saying now is, well, Nathan, these don't line up. And that's okay. This will make sense after. But for now, this is okay. I will shift this down the track, but trust me, and let's leave it for now. So this pretty much sums up our footings. We've got a couple of details we have to do. So let's put in our studs. So our studs sit up here. So from here to here, I have to draw a stud in. Now, the dimension of our stud is 90 by 45. We show it's a stud. On any of our plans, we put an X through it. So this here shows a stud, and then what I'm going to do is just draw some lines straight up, say 500. And on this side, 500. Yeah. Mirror, well, if I mirror about the midpoint of this, that should line up. Awesome, so they line up perfectly. What's next? Well, I've got a bit of brick I've got to put on here as well. So brick from here is 110. Thickness of our brick can change, but let's take 75. Let's leave a bit of a gap here. So let's allow a 10mm gap. Okay, remember what we have down here. If I look at my cross section, so I'm going to show it on that one. It would be in the rebate side, which was page 50. So here, allowing for this here. Okay, so let's come back. Actually, let's alter this one. So what we can do is we can stack bricks on, which is fine. So we can stack the bricks up like this. That's one way to show it. Or what we can do is effectively go 500, move up by 10 to allow for that gap, copy across by 110, which is the thickness, and let's just draw a line through here. Cool. Mirror about this point. No. Alright. So we're getting there. A couple more things we need to do. Well, let's come through. Let's draw. We can draw our break lines through here. Or what we can do is just draw a line across, let's say 500 to start off with. I like that number tonight. Rotate by its midpoint, 45. So 45 is a bit extreme. So let's undo that. Rotate. Let's undo this and let's get it to about there. What's that angle? No idea, but it looks good. Move. Let's move it over here. Cool. Extend to this line. Well, let's extend these. Mirror about here to there. Extend to this line now. Well, let's extend these up. So what we can see is this is a bit high. Alright, all I'm doing is proportioning by eye at the moment. And let's make them a bit shorter. Reason for that is these footings aren't very deep. So we can come through, we can hatch. Picking an internal point. Well, let's pick this one. Have we got one here for brick? What we do, this is the brick here. But that's what we use for the outside of our house. It's not really how they show it. If I come back here and look at this, this is how they're showing the brick course on the outside. So let's show it like this. Which is this one. Scale 500, not too much, 150, bit better. Cool. So brick course there. Hatch this one again. Oh. Sorry. Hatch this one. Awesome. Alright, so we're getting closer. A couple more things. Well, have I got polyline around the bottom? I do not. So let's come through, draw a polyline from here, and we're just going to go the entire way around the bottom of our footings. To here, awesome. Offset by 5. Offset this to the inside. The polyline that I've just drawn, I'm going to delete it. This polyline here, I'm going to make dashed. I'm going to change the scale. About that. So what this is showing is our damp-proof course, our damp-proof membrane, or our Forticon. All right, that orange sheet that runs around for our waterproofing. Now what's next? Well, a couple things. Let's come through and with lines again. Let's draw. Let's draw up here. So line. Let's draw another 500mm line. Rotate. Well, let's try rotate this one at 45 and see how we go. Cool. Move from its midpoint, taking the ortho off. I'm just going to put one here. Copy. Ortho back on. Let's put another one here. Offset. Let's try 50, see if that's going to be enough. Yep, 50 should be plenty, or a bit too much. Delete. Let's offset by 30. Cool. And cool. So now I've got them. Trim. Enter. Let's trim between them. Enter. Cool. So you can put in the break lines that kind of look like lightning bolts. It's up to you. But for now, this is okay. So let's stretch that out by 100. Page stretch. No, that's okay. So by doing that, I've created a massive space in here. Well, let's infill then. Well, I've stretched that out by 100. So here to here is going to be 300. So 150. Remember, this here is purely for a typical cross section. It's for the look of it. Okay, so it's to get the details across, but nobody's going to come in and look at the how spaced these are. So they are spaced at 200, but when we're just trying to come up with a section, this is sufficient. Okay, there's a level of detail we have to go into. Sometimes too much detail is irrelevant. We don't need to go that far. So we will not show the spacings of these. All we're going to do is just annotate SL92 and be done with it. Okay, they're there purely for illustration. So what's next? Well, we've got this sand, blinding sand down here we have to put in. So let's hatch that. So do we have a sand in here anywhere? Go AR sand, cool. How does that look? Well, that's not very impressive. Bit too much. 10, 5. Alright, so let's hatch these in. Alright, that's okay. That will work. It's probably not the best, but that will work. Yeah, let's alter that scale. It's going to annoy me. Let's try 7. 8. That's a bit nicer. Okay. So that's pretty much how we do our cross sections, but let's go through and annotate it. Alright. So, dimension. Well, I've got the footing width. I've got the depth of the footing. It's from the top of the slab to the bottom of the footing. These are very big, so we'll change the text and everything on them. Oh, actually, what we can do is let's have a look. I got one in here. Yes, I do. How good is that? Match properties from here. Because I'm very lazy, I don't want to change the properties of it. I'm gonna have to because they're too big again. It's okay. Alright, let's change properties here. All I'm doing here is just making the text smaller. 500, is that too big? Yep, let's go try 75. 50, make it a bit closer to that line. Arrow size is way too big. Now it's way too small. That's better. Cool. Match properties from there to there. Annotate, multi-leader. Well, what have I got? Let's say this one here is a slab. So this is a 100mm slab. This text is huge. Don't know if you can see that, but it's very big. I'm sure you can. It was a joke, by the way. So let's have a look. Arrow size, a bit too small. Let's try 50. Height of the text, try 100. Still too big. Let's try 25. Bit too small. 40. Bit better. So 100mm slab, multi-layer. This here is my SL92 mesh. Multi-layer again. Let's come through it. Let's draw one from here. So let's say it is a 8mm ligature. They can come down to 6. We try not to. 6mm when you walk on it tends to twist a fair bit. I'll explain this when I see you in class. You can actually see what this cage is. But if it's 6mm, when our concreters, who usually aren't the smallest blokes in the world, when they walk on it, it's just very uncomfortable and it twists and buckles. So W8 at say 600 centers. Awesome. So match properties from this one to this one to this one. Annotate, multi-layer, one here. This is 100mm blinding sand. And you can go through and change the properties to start off with, so your text doesn't write like this. I'm just very lazy, and this is okay for me. Yeah, let's just move it. Annotate, so last one, multi-layer. Oh, here. 2 and 12 top. Three and 12 bottom. Cool. So this is one way how to do it. It's probably not the neatest presentation of it. You can go through and customize it and do it how you would like. Obviously, I've got examples and stuff that I will show you in class. Please make sure you understand how to do this and put it all together. You will need to know how to do it in your exam. Alright, so thanks guys, and I'll see you all on Thursday.